Hello folks, this is Jennifer. Today we will talk about LeetCode 88 merge sorted array. So we're given two sorted integer arrays nums1, nums2, merge nums2 into nums1 as one sorted array. When it comes to these merge problems, we often fall into a routine way of thinking. We use a lazy way to create a new array. I'll name it merged array to store result. The array will eventually store m plus n elements, so merged array is initialized with a length of m plus n. Pointer I is responsible for traversing each value in nums1. Pointer j is responsible for traversing each value in nums2. Pointer k holds the reserved spot only for a qualified item whose value is smaller after comparison. So we compare the current values of nums1 and nums2 to see which one is smaller, and put the smaller value pointed to by pointer k into the merged array. We will continue this for loop until pointer I has traversed all the elements in nums1 or pointer j has traversed all the elements in nums2. Since here the pointer I has traversed all the elements in nums1, the remaining sorted elements of nums2 can be directly copied one by one by the end of the merged array through this while loop. Until this copying is complete, exit the while loop. We got a merged sorted array as a result. In terms of time complexity, each element of nums1 with length of m is traversed, and each element of nums2 with length of n is traversed, so time complexity is O(m plus n). In terms of space complexity, an additional array with a length of m plus n is created. So solving this question in this way, the space complexity is O(m plus n). However, the question says the final sorted array should not be returned by the function, but instead of sorted inside the array nums1, and we can assume that nums1 has the length of m plus n. So we can directly merge nums2 into nums1 as one sorted array without creating this merged array, which is an extra memory. If so, we can optimize space complexity from O(m plus n to O1. Next question, do we still comparing which value is smaller between pointer I and pointer j? For example, if I want to merge this number 2 into nums1, it is obvious it will affect a bunch of elements behind in nums1. It's kind of like when this person wants to merge into this position, it will affect a bunch of people behind. Is there a better way? We observe that this part is kind of unpolluted no man's land. Based on the given arrays nums1 and nums2 are sorted arrays, the closer to the end, the larger the value. We can scan from the end of nums1 and nums2 to see which item is larger. Pointer k holds the reserved spot for a qualified item whose value is larger after comparison. We jump into the while loop. We traverse from the end of nums1 and nums2 and found out number 6 from nums2 is larger, so number 6 is a qualified item to sit this reserved spot, which holding by pointer k. And then k minus minus, j minus minus to move to the next. And we traverse each item from the end of nums1 and nums2, and we found out that number 5 is larger. So number 5 is a qualified item to sit this reserved spot, holding by pointer k. And then k minus minus, j minus minus to move to the next. We will continue to traverse each item from nums1 and nums2, and found out that number 3 is a larger one. So number 3 is a qualified item to sit this reserved spot. And then k minus minus, I minus minus to move to the next. We continue to traverse each item from nums1 and nums2, and found out that number 2 equals to number 2. Based on if statement we wrote, it will go into this logic. So number 2 from nums2 is qualified item to sit this reserved spot. And then k minus minus, j minus minus to move to the next. However, currently pointer j is out of boundary, so we will exit this for loop. Why do we have this while loop here? Think about this test case. Pointer I finishes scanning all the elements of nums I, which is larger elements, and exit this while loop. But elements of nums2 haven't been completely merged yet. So the remaining sorted elements of nums2 should be copied one by one through this while loop. Like I mentioned, using this way is an optimized solution, so time complexity is O(m plus n). We traverse the whole given array with the length of m plus n. Space complexity is O1. We only use a constant extra space. Alright, I hope this video was helpful. If it was, please like and subscribe. It supports my channel a lot. Thanks for watching. I'll see you next time.